Now we'll see how we can find mass of lamina of some area bounded by these two curves. So we have the two curves given to us and we have to find out the mass of lamina. Now, first of all, let me explain to you what this means. That there are typically two applications. So when we say applications of double integrations, there are two applications, okay? The first application is we can find area by using double integration, and the formula is like double integration dx dy, and then you evaluate this integral over r and you will find the area. That's the first application. And second application, you can also find out mass or mass of lamina. And if you want to do that, the formula looks pretty much the same, double integration over r dx dy, except the new thing here is when you want to find the mass of a lamina, the only thing you'll write down is rho. And this rho over here is a density, okay? So if you know the density of that mass, of that lamina at any point, you can always find out the mass of lamina. So we will be using this formula, okay, to solve this question. Now, like coming back to the question, let's get started solving. So if you have to find out the mass of lamina, we will have to use this formula. So let me write down, this is mass of lamina is equal to double integration over region R. This is rho dx dy. Okay, that is the formula. Now we have to write down the region R. Okay, R, the region is bounded by y equal to x squared minus 3x and y is equal to 2x. Do you understand that y equal to 2x is nothing but a straight line? This is a straight line, right? And this is a straight line passing through origin. And if you look at this, you will see a square, okay? And it is only square for x, no y square. If it is both x square and y square, then it is definitely a circle. If it's only one of them is squared, I hope you know this is how it works. It is parabola. So we are sure that this is a parabola and this is a straight line. And when you have x square, okay, this parabola is going to be symmetric about in a vertical sense. Okay, we'll see how we can draw this. The drawing line is going to be very simple. For parabola, let me put some suitable values here. And let's see what happens. If I want to find out x and y points, tell me what if I put x is equal to 0. If I put x is equal to 0, okay, for parabola, I'll get y equal to 0. That is 1 point for sure. And let us put one smart value for x. What if I put x is equal to 3? You see, if I put x is equal to 3, this is 3 square 9 and 3 into 3 is also 9. So then I'll get y is equal to 0. So I've got 2 points, 0, 0 and 3, 0. I might as well need one more. But as of now, we'll just see that if you can draw the diagram as it is, it'll be great. So now, it goes like this. This is x-axis and this is y-axis. We know the parabola has one point is 0, 0. So it's definitely passing through origin. And one of the point is 3, 0. So let's just say this is 1, 2, and 3. So this point is 3, 0. So now let's plot the parabola, and the parabola will be like this. Okay, I'm sure you can imagine the parabola like this. So as soon as we decide the shape of parabola, drawing line is going to be very easy. It's a straight line. It is passing through origin. If x is 0, y is 0. Okay, so this line is going to be, this has slope 2. So let me draw a nice diagram for this one. So the line is like this. And let us write down the equations also. The equation of parabola, for this parabola, let me write down a label for parabola. Y is equal to x square minus 3x. And equation of a line is y is equal to 2x. I got both the equations. Now, clearly the mass of lamina, the lamina that we're talking about is this one here. And we want to find out the mass of this region. Now, this is the region R. So this is the region R. We have to find out mass of lamina for this region R. Now, to solve, and we have to find out the limits first. Just see how we can find the limits. To find the limits, I will take one strip, okay? And this is a very standard method. Let us take a vertical strip. You could take vertical strip or a horizontal strip, but vertical strip will be more suitable in this case. So if we take a vertical strip like this, the lower end of the strip is the lower limit of y. So the y lower is going to be, the vertical strip is actually moving parallel to itself. It will move all the way from here to all the way till there. So its leftmost bound, okay, is going to be y-axis, and the equation of this is x equal to 0. And its rightmost bound is going to be this line, and equation of this line will, this is a vertical line, so the equation will be x equal to this number. So to find out this line, you have to find out this point of intersection first. So let us find the point of intersection of this parabola and straight line. So the point of intersection will be y is equal to 2x. I'll put that over here. Okay. So you will get 2x is equal to x square minus 3x. So this is x square minus 3x, that will become minus 5x is equal to 0. I took that 2x on the other side, that becomes minus 2x, and this is minus 5x now. Okay, and then it is x times x minus 5 equal to 0. Therefore, x is equal to 0 and 5. Now, these are the point of intersections of what? Of the parabola and the straight line. And when you get the point of intersection of parabola and straight line, yeah, you can see one point is here where x is 0. And the other point is where x is 5. Has to be right. So this is x is equal to 5. You can always find y as well, because it is on this line. The point is on this line. And if x is equal to 5, y is equal to 10. But then nonetheless, we actually found out equation of this line. This distance is 5, right? The x coordinate, or this distance from here to here, is 5. So the equation of this line is going to be x is equal to 5. So I found out the limits of x from 0 to 5. And if you see the strip, lower end always stays on this parabola. So y lower is going to be x square minus 3x, and the y upper is always on this line. So that is equal to 2x. So we have found out the limits of x and y. Okay. Now we can start solving the integration over here, and we can find out the answer for mass of lamina. So let me clear some space for this. Mass of lamina is equal to integration. The limits of x are from 0 to 5. Do you see these two limits? X will go from 0 to 5, and limits of y, the lower limit is x square minus 3, and the upper limit is 2x. And the other limits of y are from x square minus 3x to 2x. And then this is rho. Now just see that the density, or the rho, is already given at any point, is given like this. So we have the rho value. So I can just write rho is equal to, this is 24 over 25 xy, and then this is dy dx. And I hope you already know the rule that when we have a double integration, we always solve the inner integral first. So we'll solve the inner integral, and then the answer will be integration of x is equal to 0 to 5. I can take 24 by 25 term outside. Now, while we are integrating y in this integral, we are integrating for y. Okay, so we treat x as constant. So for this integration, we're going to treat x as constant. So I can take x also out, not outside this integral, but I can just take outside this integral. And then I've got integration of y. So now this will become y square by 2. That is the inner integral evaluated. And the limits are going to be x square minus 3x to 2x, the whole dx. Now, let us solve this integration. This is 24 by 25. Integration of x is equal to 0 to 5. Well, I can take this 1 by 2 also out. So it is 1 by 2 out. And x, this term as it is over here. Okay. And let us put upper limit. This will be 2x square minus, let's put the lower limit, 2x, that's going to be x square minus 3x, and that is whole square. I'm putting the values for y and dx. Please note that the 2 is already kept outside over here. So it is 12 by 25, right? And then this is integration of x is equal to 0 to 5. Let's see how we can solve this now. This is x multiplied by, this is 4x square. Let us expand this minus. Now we're going to expand this bracket as well. So you will get x square is x raised to 4 minus, this will be 6x cube, and then outside minus will make it plus, and then this value is going to be minus 9x square. I hope you understand there's a plus 9x square, and the outside minus will make it minus 9x square and the whole dx. So I'll multiply this entire x inside and integrate. So I'm going to skip some step, but I'm sure you understood what is going on. So it is 12 by 25, and the integration of this is going to be, this will become x cube. So the integration will be 4x raised to 4 by 4, and the 4 will cancel out, minus, this will become x raised to 5. The integration will be x raised to 6 divided by 6. And then this term will become x raised to 4. Integration is 6x raised to 5 divided by 5. And minus 9. This is x cube will become x raised to 4 by 4. And the limits will go from 0 to 5. Now you don't have to put lower limit. We can only put upper limit because lower limit values are going to be 0 anyways. So let me make some space here and let us solve this and see what we get the answer as. This is 12 by 25, and then upper limit is 5. So it is 5 raised to 4 by, the 4 will cancel out. So it is 5 raised to 4 minus 5 raised to 6 by 6. Oh, I should have taken that x raised to 4 out. But anyways, 5 raised to 6 by 6 plus 6, 5 raised to 4, right? 5 raised to 5 by 5, 1 cancel out. And then you have minus 9 by 4, 5 raised to 4, and lower limit is just 0. So I'll take 12 by 25, and 5 raised to 4 I can take out. I see that's the smallest factor here. When I take 5 raised to 4 out, it is 1 minus, this is 5 square, 25 by 6, and then this is just 6, and then this is minus 9 by 4. I hope I'm doing it all correct. So I took that 5 raised to 4 out. This is 20, I took 4 out, it is 25 by 6, that is correct. So then this is 6, 5 raised to 4. The 6 remains, 5 raised to 4 is outside, minus 9 by 4, 5 raised to 4 is outside. All good. So once we get that, the answer is going to be 5 raised to 4, the 25 is 5 square, right? So it is 12, this is 5 square, and 5 raised to 4. So 5 square will cancel out, and this will become 5 square over here. I hope you understood that. 1 plus 6 is 7. So minus 25 by 6. 1 plus 6 is 7. So it is plus 7 minus 9 by 4 plus 7. Okay, so we have to solve this term as well. So it is 12 times 5 square, it is 25. And you should use calculator for this now. You can just take this as the LCM as 12. So 4 3s are 12, so that's minus 9, 27 plus 7 times 12. 12 into 7 minus 25 times 3. 25 times 3. Just simplify all this and get the final answer. I think I have the answer. So let me check what the final answer is. The final answer works out to be 175 units. Okay.